This is the video abstract for the 2025 climate paper Snowmelt Streamflow Trends over Colorado mountain watersheds by myself and Dr. Anna Pfohl. Let's think about a snowmelt-driven hydrograph. Here's an example from one of our study basins in northern Colorado. We studied 39 watersheds at high elevation that were all snowmelt dominated. Those basins varied in size from 4 to about 800 square kilometers. Here in this particular watershed, Michigan River, we see that most of the stream flow comes from snowmelt. We'll focus in for the period April 1st through the end of September, where we see most of the stream flow. Traditional methods to identify the start and end use a percentage of the total volume. So here we see the TQ20, which is 20% of the total annual runoff volume, to represent the start, which it does not represent from this graphical illustration, and the TQ80, 80% of the runoff volume, to represent the end. The orange boxes illustrate the actual start and the actual end of the snowmelt contribution to stream flow. So we use a method by Pfohl and Fassnacht presented in a 2023 hydrology paper to graphically identify the start, the TQ start, and the end, TQ end. We do a trend analysis across the 39 watersheds to assess any change in timing for the start and end of snowmelt stream flow, changes in the volume up to the start of snowmelt stream flow and up to the end of snowmelt stream flow, as well as the total annual runoff volume. We see that a majority of the watersheds are having an earlier start to snowmelt stream flow, as is seen in the literature, and a majority of the watersheds also see the end coming sooner. The end is coming, the change in the end is less than the change in the start. When we look at the total runoff volume, that is in the brown, we see that there's a mix. Some are having more water in the system, some are having less, and the volume at the end is also distributed, with some having less volume prior to the end and some having more. We investigate the why behind the trends that we see in timing and runoff volume by examining trends in land cover through NDVI, through climate variables, spatial winter precipitation from PRISM, peak snow water equivalent from the nearest snow telemetry station, and also temperatures during the melt period. And here we use March through May. We also examine basin characteristics, the elevation, solar loading through a GIS analysis, the mean slope, the area, and location. Some of the independent variables are significantly correlated, illustrated here, with the timing and volume metrics. Winter precip, some variables with peak SWE, mean slope. In the paper, we explain these correlations. We also do a number of multivariate regressions and examine maximum and minimum daily temperatures as well. So have a look at our paper and contact us if you have any questions.